Okay, we will see the demo video for the analysis and design of a vase slab staircase. Okay, so first let us see the vase step staircase, simply supported on the edges. Suppose this is our vase slab staircase and it is supported on the two edges. Okay, and this is landing 1 of length 1.2 meters, this is going of length 2.5 meters, and this is landing 2 of 1.2 meters. And say this loading is 8 kilonewton per meter square, this loading is 20 kilonewton per meter square, and this loading is 8 kilonewton per meter square. Now first what we have to do is perform analysis for this beam, right? After we perform the analysis and get the moments, we can do the design. We can design this as a continuous slab. Okay, by using we can design this staircase with a program vase slab staircase. So let us first do the analysis. Okay, we will use this program. Okay, here it is explained that this program cannot and do the analysis of an determinate structure, that is a simply supported structure, but as this program there is an limitation of this program, that it takes the load over the whole full member. Okay, so say suppose you have a partial UDL up to 2 meters, and you have another triangle VDL for say 2 meters, or you have a triangle load for falling on this 2 meters, then this program cannot take this partial loads, right? So what you have to do, we have to create a node over here and treat this as member number 1. You have to create another node over here and treat this as member number 2. You have to create a third node over here, and you have to consider this as a member number 3. So this is how you can create nodes, and then you can do the analysis and you will get the perfect answer, right? So in our case we are facing the same problem, okay, because there are two types of load. The load on the landing are different and the load on the going are different. Okay, so this is how we will give the input, right? So let us first choose a scale and say 1:10, right? So first member is x1 is 0, press enter, 0, press enter. x2 is 1.5 meters, that the length of the landing 1 is 1.5 meters, press enter, and 0, press enter. You can draw the first member, right? Now the second member, x1 is 1.5 meters, y1 is 0, x2 is the going is 2.5, so 2.5 plus 1.5, that is 3 and 4 meters, right? x2 is 4 meters, y2 is 0. Draw the member. Okay, now for the third member, x1 is 4 meters, y1 is 0, x2 is the length of the landing 2 is 1.5 meters, so 4 plus 1.5 is 5.5. okay, and y2 is 0, right? So this is third member, right? So these are the support joints, simply supported, and these are the nodes, right? So supports are to be numbered at the last. So Let us first number the nodes 1 and 2, and this is 3 and 4, right? Okay, finish. Yes, complete. Drawing is complete. We have filled the text box number. Okay, write the number of frame joints 1 and 2. Write the number of support joints 1 and 2. Okay, write the member number 3 is hinge. Okay, and 4 is also hinge, right? Okay, so this has turned to green because they are hinge support. Now we will have to give the data to the members. Okay, but as this is a continuous beam, so use manual option, right? This manual option. Okay, use manual option. Okay, click OK and press enter key. Okay, press enter key. Okay, do you want to select this member? Yes. Let us fill the property table, right? So the width, okay, width of the landing is 1 meter. Okay, so 1. Depth, depth of the base slab we are taking as 0.15 meter, so 0.15. Okay, and the loading on landing is 8 kilonewton per meter square. Okay, so just press enter and just move out of the form, right? Okay, so the data has been saved in member number 1. Now member number 2, this is going. Okay, yes, so width is again 1 meter, depth is again 0.15 meter, and the load is 20 kilonewton per meter square. Press enter, 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 and just move out of the form. So the data for this member has been given. Now this member, okay, we select this member. Okay, fill the property table. This is landing 2. Okay, so width is 1, 0.15 is depth, and UDL is 8 kilonewton per meter square. Press enter, 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 and move out the form and save the file. Say this is M. Okay, right. Now perform the analysis. Run input. Okay, now run analysis. Okay, write the actual E for the specific grade of concrete, but we are assuming this as 2E8 for just the purpose of understanding how to run this program. Okay, so let the load factor be 1 and 1, right? Finish. Okay, you can see the output. So this is the output, right? This is member number 1. Okay, the moment over here is 0, the moment over here is minus 46. Okay, minus means moment is anti-clockwise. Okay, and the moment is positive and it is clockwise, right? So this is how you get the moment at each end, right? Now you can directly go to the design section, program list, and waste slab staircase. Okay, just click this button to design the waste slab staircase, right? Okay, right, FY is 415. Please press enter key. Okay, FCK is 20. Press enter key. And if the depth of the slab is to be restrained, write 1 or else 0. Okay, so we don't want to restrain the depth of the slab, so write 0. Okay, right. Okay, so we can see the output. So this is the design for landing, this is the design for going, and this is the design for landing too, right? Okay. Okay, so Dmax is 129, right? And we have uh, taken D as 150. Okay, so the required depth for going is 150 is taken over here. Okay, so as we are not restrained, so the required depth for landing comes out to be less than 150. So this program has given has taken as 129. But if you had restrained the depth to 150, then the program would have taken the depth for both the landings and waist level as 150, right? So this is how it gives a design required for the positive steel, and the steel required in the left hand joint, that is this much for moment 0, that is 50% of this. Okay, and the required steel required at the right hand joint for moment this much. Okay, so this is how you get the design of a face slab. Okay.